Yeah.
I just want to share that. Thank you.
Yeah, they're like oh yeah, I would skip it. Yes. It did take me long. I know, and I looked at it. And like, no, I just got it done. I know, I'm gonna forget.
All right, let's get this started here, folks. Grab your pink sheet, grab your pink sheet, grab your pink sheet. After talking to my boss, I got in trouble Friday because you have to have the students memorized. All right, here they come. Grab your pink sheet. I actually used a pink highlighter. So this goes with the email I sent out. This is the exact table for the book. So grab your highlighter. Again, I just chose pink. I thought it worked well, but you can choose whatever you want. But let's highlight these. These are the ones that I will try to use on the test and nothing else. So we got acetate, ammonium, bicarbonate, bisulfate. And then let's just do this top portion here. Hydrogen sulfate is actually bisulfate. Or let's actually do this. Let's actually put it right here as well. There's hydroxide, hypochlorite. And over here, we've got sulfate, sulfite. And then carbonate, chlorate, chlorite, chromate. And it ends with phosphate down. Did I go too fast? Yes? All right, I'm going to go back up the other direction here. Back to the top yet? No, let me know. Yes. Yes, yes. All right, so we left off right here at chlorite. So chlorite is right here. Good, and then those two. So I'll change things up, so I'm pretty much using these most of the time that I can. And the other thing is, you should know this chart. On the test though, if you need a conversion, like meters to yards down here or something like that, these will be within the question. But you should know this chart here. Okay. So let's review a couple things. First of all, let's do number 9 on this quiz. Oh, before I do that, I got one email about owl did transfer perhaps. I haven't looked into it. Owl sometimes does not play nice. So make sure you submitted, and I haven't looked, that was due Sunday night, right? It seemed like owl is submitting in the Canvas smoothly. There's always going to be one person in here that it just is what it is. It just, owl doesn't play nice or owl doesn't transfer. If that happens, send me an email and I'll get to it. The other thing is, a couple announcements for lab. Like for lab, the sig figs and stuff like that, at least for my group, I should have forewarned them. It probably will be the lowest grade out of all of them, because sig figs and all that is so nitpicky in the beginning. It'll go up from there. The second lab that we have this week, you have to download the Odyssey software. I am not a fan, I'm going to tell you the truth for sure. You have to do that lab line by line by line. You have to get the Odyssey software to load. So if you haven't looked at loading that and looked at the lab closely, please do that, because you got to get that Odyssey software to load on the computer first of all. Okay, so check into that, make sure you're looking at that. All right, let's do this question here. What is the symbol for the atom that has 34 neutrons, 29 protons, and 27 electrons? So this is number 9 on our take-home quiz. So 29 protons gives us what element? 29 protons gives us copper, right? So we know we've got copper. We know we can cross out those 3 already. And we would have 29. The mass number is looks to be 63, right? And if we have 29 positive protons and 27 negative electrons, we have 2 positives left over. So it should look something like that. Okay, so that's a review on this one. I want to show you how to do 31. And maybe you looked at 31, 32, 33 and went, oh, man. I want to look at 2 of them on here. So it says, which of the following compounds is written correctly? The only way to do this is to work everyone out one by one. So if I take the first one, EOO, you assume that you have -2, -2, -2 for the oxides, right? It can't be peroxide. The peroxide would be O2 in parentheses. Then this boron would have to be a +6. And then you look at your sheet, is there such thing as a boron 6?
No.
No, so that's junk. Right? There is no boron 6. So you go to the next one. You got B, and you've got W, CO3, CO3, CO3. And that CO3 in parentheses has to be carbonate. And the ion charge of carbonate is -2, -2, -2. This gets us a tungsten 6. Is there a tungsten 6? I think there is, right? So right now, it looks like this should be the right answer. And if you can verify that quick. If we do letter C, you have Li, Cl, Cl. Now the chlorides are -1 each. So we have -1, -1, that would give us a lithium of +2, which is junk. Lithium is always +1, right?
Right.
Remember, you always know what the negatives are. And D, you have zinc. I guess I could do it like this. 2 zincs and a sulfide. The sulfide's -2 always, which make the zincs +1, and there's no such thing as a zinc 1, they're always zinc 2s. In letter E, you got calcium oxide. So -2, -2, -2. Because of the 3 oxides, make it a calcium 6, and that's just garbage too, right? There's no such thing as a calcium 6. So that's how you got to do 31, 32, 33, 34, 35. You just got to you got to look at them one by one. Then let's look at 36. Find the oxidation state of the underlined ion. So you have, this is just phosphate. Remember, we treat this as one ion bound together, but overall it has a charge of -3. These are all -2 oxides. So what's the charge? That total right there is -8. So the charge of my phosphorus is +5, right? It's +5 phosphorus within phosphate. In 37, you have phosphate, you have tungsten, and you have aluminum. And 2 out of the 3 are locked in. Treat it like this: 1, 2, 3, 4, 5, 6. You got 6 phosphates. You know the charge of the 6 phosphates. You know the charge of aluminum because it cannot change. So that will allow you to calculate the tungsten. Okay. All right. So that's a little bit of help with that. Let's work on this first, and then we'll go into talking mold. We'll delay the mold talk for a little bit. Now, again, you have the answers to this posted out there. Or anything that tripped you up on this? After you look at the answer, anything that really doesn't make sense? So we went through what, page 5 or so. All right, let's look at page 6. Now, this kind of gets us a jump start on a later chapter too, because acids come up in a later chapter. But since you're working with lab stuff and we're already doing formulas of compounds, I thought, well, it makes sense just to do acids. Then we have a jump on things later. Okay. So formulas for acids. For our version at this point, an acid is going to start with hydrogen with a positive charge, followed by a negative ion. So just figure hydrogen with a +1 charge. And by the way, what is hydrogen with a +1 charge? It is only a proton. This is a proton. That's it. Because hydrogen, atomic number 1, starts out 1 proton, 1 electron. If it's not a neutral hydrogen atom, it doesn't have its electron anymore. The only thing this right here is a proton. 1 single proton. So we know that these are going to start with hydrogen with a +1 charge. Okay, so for a non-oxyacid, this is no oxide. They are all going to start with hydro and end in ic. So, first of all, when you see the word acid, you can do this for every single one. When you see the word acid, for our definition for right now, we can do that. And then this is going to be the negative ion on the pink sheet. This is going to be iodide. This is going to be sulfide. This is going to be chloride. We're looking for a single, typically a single negative ion. In fact, it's the same as hydrogen iodide, hydrogen sulfide, hydrogen chloride, hydrogen fluoride would be the same thing. So iodide, I, -1. So that's it. Sulfide. That's -2. So that's H2S. And there's some freakish things. I have arrows. So you would think this would be hydrosulfate acid. Because we just cut the "ide" off and replace it with "ic," but sulfur compounds keep the "ur." So this is the same as hydrogen chloride. And this is the same as hydrogen fluoride. Okay, and the oxyacids. And some of you have seen, it goes like this: my ride has hydraulics. I don't know if you've seen that mnemonic for these. A couple of mnemonics. So down here we have oxyacids. So we're gonna have oxides in those. Notice none of the names start with hydro. And there's a mnemonic for these. And these are pretty good for this. So if the negative ion ends in 8 from the name on the pink sheet, then you're going to name the acid as ending in ic or 8 to ic. And if the negative ion ends in ITE from the pink sheet, then the name for the acid is changed to OUS. Or Sprite is delicious. So here you see OUS. So what are we looking for on our pink sheet? Something that is close to that as ITE, right? Here, 8 has replaced with ic, so we're looking for 8 here. So we can go down here. Anything with OUS, we're going to be looking on our pink sheet name as ITE and so on. Phosphorus compounds, the OR is in there. So on our pink sheet now, and one of them that's highlighted is, no, it's not, I like it. Top up here, phosphite. So if this ends in OUS, we're looking for ite on our pink sheet, and this is the closest thing we're going to find. So this is the same as hydrogen phosphite, which is PO3 negative 3. So we're going to end up with H3PO3. Now the rest of these, we're going to put our hydrogen in again. Put your H plus 1 all the way down. Put your H plus 1 all the way down. Then these are pretty quick now. You're just looking for here, you're looking for carbonate, you're looking for cyanide, and you're looking for chlorate. So we can simply look up these negative ions now. And perchlorate is one for sure that you should have memorized. Nitrate you should have memorized. Carbonate you should have memorized. And chlorate. Those are the ones. But perchlorate. Oops, should be ClO4 negative 1 for perchlorate. Selenite. CO3 negative 2. Nitrate. NO3 minus 1. Carbonate. CO3 minus 2. Cyanite. OCN minus 1. And chlorate ClO3 minus 1. So let's summarize this here. Every one on 1 through 7 has oxides. All right? They all have oxides. None of them start with hydro. None of these have oxides. We know it's an acid, it starts with hydrogen. They do not have oxides. They're going to start with hydro and hydro. So on the next page, we write the names. We know these are all going to start with hydro. We know they're all going to end in ic, and then we're going to add the uric acid. So now I'm going to switch colors. This is the same as hydrogen bromide. We have hydrobromic acid. HF is F is fluoride. We have hydrochloric acid. Oh, I didn't put an arrow on number 3. You would think number 3 would just be hydrosulfuric acid because it's sulfide, but it's actually hydrosulfuric. And number 4, this would be telluride. So hydrotelluric. Now, the bottom ones are really, really easy. All we have to do is look up this negative ion on the pink sheet and go 8 to I to us. So number 1, the SiO3 is metasilicate. And we're simply going to cross out the 8 and change it to it. You should pronounce that metasilicic. PO4 is phosphate. So if it ends in 8 for the negative ion, the name is going to end in ic. So, and actually, this is one of those freakish ones. I've got an arrow, so this is going to be phosphoric acid. SeO3 is selenite. So we're simply going to take the ITE and replace it with OUS. We'll do this one and then we'll move on here. S2O8 is peroxydisulfate. So we know the name is going to end in ic, and this is going to be peroxydisulfuric. So the rest don't have any weird things. You're just going to look up the negative ion, replace 8 to ic. So I'll let you do that. And then the next page does the same thing, and it's kind of gotten mixed up. So I just want to point out number 1 and number 2 on page 8. So number 1 is going to start with hydro, right? So this is going to start with hydro. This ion here is phosphide. So this is going to be hydro. Phosphoric. Did I spell that right? That doesn't look right. Where PO4 is phosphate. Oh, that's an O, that's why. This is an O. So hydrophosphoric acid, and down here, we're simply going to have phosphoric. So hydrophosphoric and then phosphoric.
Why is that one just phosphoric and not hydrophosphoric?
Because this one has oxides in it, So then if it has oxides, it's not going to start with hydro and end in ick. You're simply going to look up the negative ion.
Okay, thank
Yep.
you.
So remember, if you're looking at something that starts with hydrogen, does not have oxide, it has to start with hydro and then ick. If it has oxide in it, you're not going to have a hydro. You're just going to go 8 to ick. Okay, let's do this. I'll let you look at those answers that are posted out there. Then there's just one last thing. Then that's some hydrates here on the last page. So hydrates have water locked within their crystal structure. And to signify how many waters are locked up, we use a multiplication dot and we put a number H2O. And the numbers come from this chart. So not much different. We're just going to put a multiplication dot to signify the hydrates here. So for this first example, calcium sulfate. Forget about the trihydrate. Calcium sulfate, first of all. Calcium plus 2. SO4 minus 2. So that's just calcium sulfate, right? Trihydrate, multiplication dot. Tri is 3. And the word hydrate is simply H2O. So nothing overpowering there. It's just using the same prefixes, multiplication dot, same prefixes, and H2O. So down here, this is a very common one. CuSO4, Cu is copper. And SO4 is sulfate, right? And we need Roman numerals, SO4 being sulfate. And the 5 is penta. And the water is hydrate. Yeah, copper 2 sulfate, pentahydrate. Got a Roman numeral 2. Okay. So use the answer key that I have for this and try to go through this. Try to work out, because we're not getting the other quiz much at all. So try to work on this and get all these worked out. Please don't look up, don't go to the internet and look these up. If you go to the internet and look things up, like even if you look up table salt, it gives them in alphabetical order. It's like it tends to do this stuff. And please, 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 please start looking at the ingredients in the foods and stuff you are eating, so that you are not eating something like this. I gotta make sure, go back to sharing the screen.
Delivers up to 16 hours of targeted pain relief. Real heat, real healing.
So we heard over the weekend, a woman in Cincinnati bought the Walmart ice cream, great value brand, ice cream sandwiches for kids. Left it out in the sun and it didn't melt. So you go, hey, that's not real ice cream in there. So we're gonna check it out. We're gonna see how long it takes on a sunny day, for the most part sunny day, and about 80 degrees. It's not. So as you can see, now we put an ice cream sandwich out on a little plate, out in the sun. And we're gonna see how long it takes for it to melt. The temperature is 78 degrees. Clock exactly.
There's 20 minutes later at 80 degrees, and you know that plate is gonna be warm, right? That's not just a cool plate. So if it's 80 degrees outside, that plate is holding a lot of heat. That's 20 minutes later. 20 minutes. 35 minutes.
Ice cream sandwich.
And the guy put a real scoop of ice cream on the other plate. Don't be buying this stuff.
Not the box. 80 degrees, if not 80 degrees.
I don't know how they get away with that stuff, but it's just methyl cellulose and a bunch of fillers and crap. So don't be buying that stuff. Okay, let's go back to. Make sure I get the right screen. Okay. Now, again, this should finish this up. So you're going to do the same thing in Canvas. You're just going to enter the answers, right? Okay. Now, let's go to this video. Okay. So on the front of this, copper, 1 mole amount, 63.546 grams of copper in 1 mole of copper. Tin, 118.71 grams. Magnesium, 24.305, and sulfur, 32.066. Hopefully, it maybe registers a little bit that matches the exact number listed for the mass of a single atom. Remember, this is the mass of a single atom in atomic mass units. An atomic mass unit is like 1.66 times 10 to the minus 24, 27 grams. You are not going to go to the balances in the lab and weigh out a copper atom, right? But if you have a mole of copper, it's 63.546 grams. And how many are in a mole? How many atoms are in a mole? Avogadro's number, 6.022 times 10 to the 23rd, right? That is significant. Now, it would be no different if we could list all the eggs in the world. How many different eggs are there? There's chicken eggs, and there's ostrich eggs, and there's pigeon eggs, and there's, I don't know, all kinds of eggs, right? If we did a chart like this and said, instead of a mole, we're going to call it a dozen. If you had a dozen eggs of those different sizes from all the species, you could come up with a chart like this, right? Of the number of the mass of a dozen eggs. This chart is no different. It is a mole. Each one of these is a mole if you use this number in grams. And how many are in a mole? 6.022 times 10 to the 23rd. So if you went to the balance in the lab and massed out 63.546 grams of copper, you would have a mole. Or any ratio of that, 6.3546, if I move the decimal point 1 to the left, would be 1/10 of a mole, right? So again, all of these numbers here in red on your periodic table, we can use grams if we are talking a mole. And a mole is a pretty darn large number. Very, very large. Very, very large. So these are 1 mole quantities. But now if we get down here, if we have a mole of water, H2O, it's 18.02 grams. And where do we get that? We get that because oxygen is 15.9994. And hydrogen is 1.00794. So when we're talking about the molar mass of a compound, we have to add these up, right? 2 hydrogens and an oxygen to come up with the 18.02. Individually, this is 1 oxygen. This is individually 1 hydrogen. So aspirin, 9 carbons, 8 hydrogens, 4 oxygen, and so on. So let's do that on the next page. We'll grab our calculator. So what is the molecular weight, molar mass of ibuprofen? Oh, we're going to have 13 carbons, 12. Let's see, I wonder if we should go. I like to go 2 decimal places all the time. Let's go 2 decimal places. So 12.01. We have 18 hydrogen. And here's where we get messed up. I like to do 2 decimal places, except for like hydrogen. I like to do 4 just on the hydrogen, because that keeps 4 sig figs. And then we've got 2 oxygens. So oxygen, 15.9994. We're going to round that to 16. So your calculator will do that. Just grab your calculator, run that through. And if we did 4 sig figs, 206.3. Anybody 206.3? So 206.3 grams in a mole. In mole, we can take the E off. So this is aluminum sulfite. So we have 2 aluminums. Plus, how many sulfur? Yeah, 3 sulfurs. And if we look up sulfur, it's 32.065. The new way around it would be to make that a 6, but we'll go 32.07. And how many oxygen? 9 oxygen. Two 94.2. 294.2. Okay. All right, there might be some multiple choice review there. You know, looking at what we're going to do next time we meet, we're going to crank out all these moles. It's going to be calculator day, calculator day. Make sure you bring your calculator to verify. Grams to moles, moles to grams, grams to moles to atoms, grams to moles, moles to grams, grams to moles to molecules to atoms, and so on. Then it's empirical formulas, molecular formulas, percentage composition. Make sure, try to get that roll sheet signed. Try to get Odyssey loaded for your lab. Make sure you look at the pre-lab stuff.